All right, we need to evaluate this without using a calculator. So last week we talked about how to do that, and we said anytime we have an inverse trig function, we're going to replace them with letters, and then we also said that for every inverse trig function you have to do what? You remember?
Draw a triangle.
Draw a triangle. So we're going to draw a right triangle. We're going to draw two of them because we have two inverse trig functions. Okay? One triangle is going to be A, which is the same thing as the inverse sine of 3/5. That's 3/5. And then the other triangle is going to be B, which we're saying is the inverse tangent of 2, which is going to be 2/1. Okay? So we're going to use this information to figure out all the sides of the triangle, and then we have to find sine and cosine for each triangle. Okay? So inverse sine 3/5, sine is opposite over hypotenuse, so what's the other side going to be? 4. So what is sine A equal to? 3/5. Yay. And cosine A is equal to 4/5. Okay, so just like we did when we first started trig. And then the tangent is going to be opposite over adjacent. So what is going to be the hypotenuse on this one? Square root of, what's 4 plus 1? 5, right? Pythagorean theorem. So what is sine B? 2 over square root of 5. Good. And what is cosine B? 1 over square root of 5. Okay? Now, we know what the sum and difference formula is for cosine A minus B. What is it? Cosine A. Cosine B plus sine A sine B. And we know what all of those are because we just found them from the triangles that we just drew. So cosine A is 4/5 times cosine B is 1 over square root of 5 plus sine A is 3/5 and sine B is 2 over square root of 5. That equals 4 over 5 square root of 5 plus 6 over 5 square root of 5, right? Which equals 10 over 5 square root of 5. And if we wanted to simplify that, that would just be 2 over square root of 5. Okay? Does the direction say you have to simplify? No. So either one of those would be correct. All right, so we're going to do the same thing here. You're going to have sine A minus B. And we have two inverse trig functions, so we're going to draw two triangles. There's one. There's two. So this first one will be A, and it's going to be the inverse tangent, not sine, of 1/2. And the second one is going to be B, which is the inverse sine of 1/2. Yeah, it's just easier. All right, so tangent is opposite over adjacent, and this is the same triangle as what we had on the last one, so this is going to be the square root of 5. So sine A is going to be what? Right, 1 over square root of 5, and then that means cosine A is 2 over square root of 5. Okay, then over here, sine is opposite over hypotenuse, so the third side is going to be what? 4 minus 1 is 3, square root of 3. So then what is sine B? 1 over 2, and this would be square root of 3 over 2. Okay? So now we've got sine A minus B right here. What is the identity for sine A minus B?
Sine A cosine B
right? Minus, right, cosine A, sine B, or you can put them in the other order, it doesn't matter. And now all we do is we fill in. So sine A is 1 over square root of 5, and cosine B is square root of 3 over 2. Minus, cosine A is 2 over square root of 5, and sine B is 1/2. Square root of 3 over 2 square root of 5, minus 2 over 2 square roots of 5. So you have square root of 3 minus 2 all over 2 square roots of 5. Here. All right, so how many inverse trig functions do we have? We have 1, right? So this will be sine 2a. So how many triangles do we have to draw? Just the one. So A is going to equal the inverse tangent of 3 over 4. Okay? So tangent then again is still opposite over adjacent. So what's going to be our hypotenuse on this one? It's 5. What is sine A? 3 over 5. And what is cosine A? 4 over 5. So now you've got sine 2a, which is the same thing as sine 2 theta. It doesn't matter if it's an a or a theta or an x. You have a 2 in front of your angle, you should immediately be thinking, oh, that's a double angle. So what's your double angle formula for sine? 2 sine A cosine A. And now we just plug them in. 2 over 1 times whatever sine A is, 3/5 times 4/5 equals 24 over 25, and you're done. Or tangent, this is all we're doing here. So write tangent A. Does everybody see that? We only have one inverse trig function, so we're going to draw one triangle. So this is A right here, and it equals the inverse cosine of x. So I'm going to make it x over 1. Anytime I just have an integer, or in this case a variable, I'm going to put it over 1. So cosine is what over what? Adjacent over hypotenuse. You can still find that other side. Okay? It's always going to be the square root of the hypotenuse squared minus the other side squared, right? That's Pythagorean theorem. So what's 1 squared? 1 minus what's x squared? X squared. That's it. Now, do we have to do any fancy formula to find tangent A? It's just tangent A. So you have the triangle with A. Tangent is what side over what side?
Opposite over adjacent.
It's just opposite over adjacent. So we don't have to do anything but find tangent. So tangent A is opposite over adjacent, and you're done. Okay, this is sine 2a. So how many triangles are you drawing? One triangle. It should look exactly like the one we just did. So here's A equals the inverse cosine of x over 1. So that's adjacent over hypotenuse, and we just had on our last one, this is 1 minus x squared, square root of that. Okay? Sine 2a, what's the identity for that? 2 sine A cosine A. So that's going to be 2 over 1 times, I guess I should figure out what sine A and cosine A are first over here. Sine A is going to equal a square root of 1 minus x squared over 1, so I don't need to put it over 1, do I? No. And cosine A equals x over 1, which is just x. You want me to put them over 1? All right, for some people it might make them feel a little bit better. All right, so this will be, that's red. Let's try green. That'll be square root of 1 minus x squared over 1 times x over 1. So all the ones on the bottom are fine. You end up with 2x square root of 1 minus x squared. And that's all you have to do on that one. This is going to be cosine 2a. It's going to be the same type of triangle that we've been doing, just the sides are going to be flip-flopped. So this is going to be inverse sine of x. So you have to remember it's the same type of a deal. Sine is, it's x over 1, I guess. So it's opposite over hypotenuse. So it's still the same triangle we've done on the last two problems, just the sides are switched. So this will still be the square root of 1 minus x squared. Okay? Sine A is going to equal x over 1, which is just x. Everybody good with that this time?
Yeah.
And cosine A is just going to equal what? Square root of 1 minus x squared over 1, so you don't really need to put the over 1 part. Okay? So what is the formula for cosine 2a that you want to use? Cosine squared theta, or a in this case, minus sine squared a. Okay, and then we just plug in. So cosine is square root of 1 minus x squared. So square root of 1 minus x squared minus x squared. What happens when you square a square root? Yeah, it goes away. So you got 1 minus x squared minus x squared. When you put that together, what do you end up with? 1 minus 2x squared. Yeah, that doesn't matter what order. If you have negative 2x squared plus 1, it's the same thing. Okay. All right, we're going to change from a product to a sum and then apparently simplify. So you need to look on your notes and look at the sine, product to sum formula. So, all right, so we got 10 times, the 10 just stays there, so it's times 1/2 bracket what? Cosine.
A minus B.
And what is A in this case? 5x minus 3x minus cosine.
A plus.
And so that'd be 5x plus 3x. Right? Everybody see that formula?
Yeah.
So we're just plugging in here. So then what's 10 times 1/2? That's 5. What's 5x minus 3x? 2x. What's 5x plus 3x? 8x. All we have left to do now is distribute the 5 through. Remember, you're distributing it to the front of the trig functions. Don't try to multiply it times the angles. You can't do that. So this would be 5 cosine 2x minus 5 cosine 8x. All right, what is the cosine sine product to sum formula? 1/2. So that would be 2x plus 8x.
Minus sine. A minus B.
2x minus 8x. Right? Okay. So then we can put this together. What is 2x plus 8x? 10x minus sine negative 6x. Okay, now listen. You just wrote down notes on even and odd functions, right? So this negative that's in this angle right here, what do I do with it? Assign an odd or an even function? Odd. So what do we do with the negative on an odd function? Move it out to the front. Okay? So that, what's a negative negative? A positive. So this becomes 1/2 sine 10x plus sine 6x. Because we got to move this negative out to the front. Okay? That would be simplifying, so you need to do that because the directions tell you to. Oh, I forgot something here. What did I forget? Yeah, I forgot the 1/2 right here. All right, somebody tell me what the cosine formula. Did it say to write them as a product?
The same direction.
Same directions? All right, let's just go ahead and do it then. We could actually just solve this, but let's do it where we change them from product to sum, and then we'll do it the other one and see if they're the same. So what's the cosine formula? 1/2.
Cosine. A plus B.
So 90 plus 180
Plus.
plus 90 minus 180. And this is not probably the ideal way of doing it, but we're going to do it this way because that's what we're learning. So this will be 1/2 cosine 270 plus cosine negative 90, right? All right. What's that? You can take the negative off, yes. If you, well, cosine negative 90, yes, you can. You can take it off. It's an even function, so if you want to, you can do that. So 270 plus cosine 90, because it's an even function. But it doesn't really matter, because you're going to draw a picture, and 270 is right here, and 90 is right here. Well, what is cosine? What direction does it go? And you're not going left and right, so what's cosine 270?
0.
It's 0 plus, what's cosine 90?
0.
And what's 1/2 times 0? 0. Now, you could have just said up here at the top, cosine 90 is 0 times cosine 180 is what? Negative 1. What's 0 times negative 1? 0, and you would have been done. Okay, so we can either choose to change this from radians to degrees now, or we can do it at the end. It really doesn't matter. What do you want to do?
I should do it now.
All right, you want to do it now. So what is pi equal to in degrees? 180. So 3 times 180 is 540, and then this is just 180. Now you need to look on your note cards to see what the formula is for cosine sine product to sum formula. Okay? And I believe it starts 1/2.
Right.
Then what's next?
Sine.
A plus B. Your A is 540 and your B is 180. So you've got 540 plus 180 minus sine, you said? Is that right or wrong?
No, sorry, minus sine.
Minus sine,
A minus B.
540 minus 180. Okay? So this is going to be, what's 540 and 180? That's what, 720? Yes? So you have sine 720 minus, and 540 minus 180 is what? 360? Okay. Yeah, no, it'll be on your note card. All right. When you distribute the 1/2 through, you need to make sure you do not distribute it through to the angles. It just stays in front of the trig function. Okay, so it's 1/2 sine 720 minus 1/2 sine 360. Now here's, and you could have done that later if you wanted to solve the inside first. We actually have to solve this because it tells us to simplify. Well, 720 and 360, what can you tell me about that? Aren't they in the same spot? This is 360, and if you go around again, it's also 720. Sine goes what direction? Up and down. So what is sine 720 going to be? 0. And what's sine 360 going to be? 0. And what's 0 minus 0? 0. Okay? You also could have, now we're doing this because that's what the directions say to do, but you could figure out what cosine 540 is, and then you can figure out what sine 180 is and multiply them together without changing them into a product and sum. Not a product and sum, a sum or difference. Okay? Okay, so now you're changing it from a sum or difference to a product. So you need to look at your notes underneath sum to product formulas, and you look for the one that says cosine minus cosine. 5x is your A and 3x is your B. Yep. Okay, so what's the formula for cosine minus cosine? Isn't there something in front of it? Negative 2 sine what? 5x plus 3x over 2. 5x minus 3x over 2. Okay, and then we simplify. So this will be negative 2 times sine, what is 5x plus 3x? 8x. And what's 8x divided by 2? 4x. And then what is 5x minus 3x? And 2x divided by 2 is just x. You can't do anything else to this. You can't combine anything or anything else, so you just leave it. Okay, make sure you don't try to combine these together. You cannot do that. So you need to use your sum to product formulas again. So what's the sine minus sine formula? 2 cosine. So A is 75 plus 15 divided by 2. Sine 75 minus 15 degrees divided by 2. And then we simplify that. So you've got 2 cosine. 75 and 15 is what? 90. So what's 90 divided by 2? 45 degrees. Good. Sine, what is 75 minus 15? 60. And 60 divided by 2 is 30. Now this one has actual angles, so we can solve it. So we'll make the 2 over 1. What's cosine 45? Square root of 2 over 2. What's sine 30? 1/2. Can I simplify anything? A 2 from the top and one of the 2's on the bottom. And so what am I left with? Square root of 2 over 2. So do you guys want to change from radians to degrees first? Okay. So what is 180 divided by 12? 15? So this is cosine 15 degrees plus, so pi over 12 we just said is 15, right? So for 7 pi over 12 you just take 15 times 7, which is 105, right? Okay? You can do it in radians and then at the very end change it to degrees, or you can change it early. Most people like changing it early, it doesn't matter. Now you look at your sum to product for cosine plus cosine, and what is that formula? What's the cosine plus cosine? 2 cosine 15 plus 105 over 2. Okay? It's cosine again. 15 minus 105. Okay, good. So now when we solve this, we get 2 cosine 15 and 105 is 120. What's 120 divided by 2?
60.
60. Okay, good. Cosine 15 minus 105, is that negative 90? What's negative 90 divided by 2? Negative 45. Now, this is where that even and odd function can come into play, because we have a negative angle, and cosine is our trig function. Is cosine an even or an odd function? It's even, so what do I do with the negative sign?
Get rid of it.
I can just get rid of it altogether and just make it that. And now I can go ahead and solve. So I'll make the 2 over 1. What's cosine of 60? 1/2. What's cosine of 45? Square root of 2 over 2. Can I simplify anything? 1, 2 on the top, 1, 2 on the bottom, and we're left with square root of 2 over 2. All right, we're going to verify each identity, and that means we need to make sure that at the very last step, both sides are the exact same. Okay? So we talked about this on Friday, or that we want to make sure that if we've got a fraction with a bunch of products, or not products, I just gave you the answer, sums or differences, that we want to change them into products, because then we can cancel things out. Okay? But first we can go ahead and change this left-hand side. What is cotangent x the same as? Cosine over sine. Okay? And now we're going to use our sum to product formulas, because that's going to make it easier for us to cross things out. So we need to look for the one that says cosine plus cosine for the top there. Okay, so what is it? What's that going to be? And 3x is going to be your A and 5x is your B. So you're going to get what? 2 cosine, so 3x plus x over 2. And then what? Cosine 3x minus x over 2. Good. We're done with the top. So now we need to do the bottom one, which is sine minus sine. So what is the formula for that? 2 It's cosine? Cosine what? 3x plus x over 2. Sine 3x minus x over 2. Okay? And now we go ahead and simplify these things a little bit before we start crossing stuff out. So you've got on the top 2 cosine, what's 3x plus x? Divided by 2 is 2x. And then what's 3x minus x? 2x divided by 2 is x. Okay, good. And now we do the bottom part. We simplify it all up. And we got the same thing here. So 3x plus x is 4x. Divided by 2 is 2x. And then you have sine 2x over 2, which is just x. Well, now what can you cross out? The 2, the cosine 2x, and you're left with what? And isn't that what we wanted? So we verified the identity. All right, what did you change negative tangent 4x to? Right, negative sine 4x over cosine 4x. Okay? So that shouldn't be too bad. Then we have to do the cosine minus cosine formula. So what's the cosine minus cosine formula? Negative 2 sine what? 3x plus 5x over 2. 3x minus 5x over 2. Okay, then what is the sine minus sine formula? 2 what? Cosine. Okay. Now we can simplify these things. So you've got negative 2 sine, what's 3x plus 5x divided by 2? 4x. Sine, what's 3x minus 5x divided by 2? Negative x, right? Isn't it just negative x?
Yeah.
Okay, and we could move the negative out in front of the sign if we wanted to, but let's just see how the bottom shapes up first before we do any of that. So then you've got 2 cosine, and what's 3x plus 5x divided by 2? 4x. And then what's sine 3x minus 5x divided by 2? Negative x again, right? So what crosses out? The 2's and the what? Sine negative x's, and that's it, right? So what are you left with? Negative sine 4x over cosine 4x, which is exactly what we had on the other side. What is cotangent 2x the same as? Cosine 2x over sine 2x. Good. Equals. Then you have the sine minus sine sum to product formula. So what's that one? 2
Cosine x plus x.
3x plus x over 2.
Sine
3x minus x over 2. Okay. Over 2 what? Sine 3x plus x over 2? Then sine 3x minus x over 2? Is that right or wrong?
Wouldn't it be like x minus 3x? On the bottom it's split. It's covered by x. Minus cosine 3x. See the original problem?
Yeah, but is this the formula though? This is negative 2 right here? Okay, so is that right?
Yeah.
Now?
Yeah.
These ones on the bottom are both sine though.
Yeah.
Okay, so then we simplify. So 3x plus x is 4x divided by 2 is 2x, right? And this is going to be sine 2x over 2, which is just x. Is that correct? And you said this is it negative on top or just on the bottom? Huh. This isn't right then. Are you sure these are the right formula? Does it work? Oh, because what's on the bottom that's wrong?
The x plus 3x over x.
Yeah, that's what I was trying to say.
This should be, should be reversed. That's right. Okay. I didn't look at the problem carefully enough. All right, so it should actually be x plus 3x. All right, now it makes sense. And this should be x minus 3x over 2. All right, now it makes perfect sense. All right, so then you've got negative 2 sine, that's 4x over 2, which is 2x. And this will be sine negative x, right? Sine is what kind of a function? Odd. So the top is 2 cosine 2x sine x over negative 2 sine 2x times negative sine x, right? Well, what can I cross out now? The 2's.
Negative.
The sine x's, right? Well, how many negatives do I have on the bottom? 2 of them. What's a negative times a negative? A positive. So we're left with cosine 2x over sine 2x, which is the same thing that we had over here.